Hi everyone, welcome back to the channel. We're going to be solving question 7 from the 4th chapter of the Hibbeler textbook, and in this one we need to determine the moment of each of these three forces about point A. So we're going to use the 2D shortcut that we have for finding the moment in these kind of questions, and what we're going to do is we're going to dissolve each force into two x and y components. We can call our x and y in here. So xy. Let's start with the f1. So if we want to dissolve f1 to x and y component, this will be our y component, and this will be our x component. So if you look at the x component, we'll see that it's along the point A, so it won't make any moment, and the only moment that we have is from the y component, which will be f1 cosine of 30 degrees. So we're going to do the same thing for the other two forces that we have in here. We're going to dissolve f2 in x and y component, same as the other one. And if you look at this again, the x component is going to pass through the point A, so no moment from the x component. We know this angle is 60 degrees, so the y component here would be f2 sine of 60 degrees. So f2 sine of 60 degrees, that's the only force or the component of f2 that makes moment. And the last one would be the f3. Again, we have these two as x and y component. This time both x and y component of f3 is going to make moment about point A, so we have to consider the moment from both components. And if we want to find the x component, we have f3 3/5. So if you look at this right triangle, for x component we have the horizontal side, which is 3 over hypotenuse, and for vertical one we have f3 times 4 over 5, and 4 is the y component. So now we're good to go to start our moment, and I'm going to go with color of each force. Let's start with the f1. We're going to find the moment of f1 about point A. As always, we're going to call counterclockwise positive. If we look at f1, we'll see that the moment about A is in a clockwise direction, so we have a negative sign. And here we only need the force. So the force we figure out is f1 cosine of 30, so 250 cosine of 30 degrees. And the distance that we have is the distance from the point that we are finding the moment about to the line of action. This is the line of action, so the vertical distance is what we have for 2. So basically 500 cosine of 30 is going to give us the moment of f1. Let's calculate this. 500 cosine of 30, that's going to be minus 433, and the forces that we have are Newton, and the distance is in meter. So that's the first moment. Let's move on to the second one, or f2. Again, the x component, no moment. We only have the moment of the y component, so we are looking for the moment of f2 about point A, counterclockwise positive as always. And if we look at f2, we'll see that about A, again, we have a clockwise moment, so another negative sign in here. The force this time is 300 Newton, so we have 300 sine of 60. And the vertical distance to the line of action would be what we have from here to here, or 2 plus 3, or 5. So 5 times 300, 1500, so 1500 sine of 1500 times sine of 60, that's going to be minus 1299 Newton meter. And again, the negative sign in here shows the moment is clockwise. So we can just put it clockwise in here too, both work. The negative sign is actually showing that, so don't need to put that in, but we can also show it in that way too. And the last one is the moment of the green one, or moment of F3 about A, counterclockwise positive. So we have two moments here. We have the moment of X component, which is F3 times 3 over 5. This moment is counterclockwise, so positive. So plus F3 we know is 500 times 3 over 5, and the distance, don't forget the definition, the vertical distance to the line of action, which is 4. So that's 1. And let's move on to the Y component. Y component, as we can see, the moment is clockwise, so we have a negative sign for that, minus 500 times 4 over 5 times the vertical distance to the line of action. This is the line of action, and we have, again, same thing, 2 plus 3 or 5. And all we need to do in here is to calculate this one. So basically we have 500 times 3 times 4 divided by 5 minus 500 times 4 divided by 5 times 5. And that's going to give us minus 800, again, Newton meter, and the negative sign shows that the moment is clockwise. So yeah, that's pretty much everything. We solved this question using the 2D shortcut that we have. There's another method that we can solve this question, and for that one we need the vertical distance from A to each of these forces. So for F1 we need that one, and same for the other one, we have to find the line of action and find the vertical distance to those. But it might get confusing, and this is the most common way to solve these types of questions. You just dissolve every force into X and Y component, and you go with the 2D shortcut, and it works in all the cases. Hope everything was clear. Let me know if you have any questions. We are covering 3 different textbooks in this channel. Let me know if you have any specific problem from these textbooks that you want me to cover in the next videos. And you guys take care. I'll see you in the next video. Have a good one.